Okay, welcome to another video. This is May-June 2019, paper 2 multiple choice extended question. Remember to subscribe to my YouTube channel so that you can have regular updates on the various resources with regard to your exam success. Okay, so let's move on straight to question 1. Which statement explains why ammonia gas diffuses at a faster rate than hydrogen chloride gas? So looking at this option, you cast your mind back to factors that affect the rate of diffusion of gases. Okay, the first option here says ammonia expands to occupy all the space available. Ammonia has a smaller relative molecular mass than hydrogen chloride. Ammonia is an alkaline, hydrogen chloride is an acid. So the pH, the acidity or alkalinity of a substance does not affect the rate of diffusion. Okay, recalling the factors that affect the rate of diffusion, you have temperature. Okay, you have temperature affect the rate of diffusion. Apart from temperature, you have the mass affecting the rate of diffusion. Okay, now apart from this, okay, you have distance that the particular substance has to travel, and the availability of other substances present there, concentration if you like. Okay, concentration if you like. So out of these factors we are looking at mass here. Okay, so ammonia has a smaller relative molecular mass than hydrogen chloride, so this is something that has to do with mass here, but we need to confirm whether this statement is actually true. So how do you calculate the relative molecular mass, okay, for your molecule? Ammonia, that's your NH3. Okay, nitrogen is 14, okay, plus 3, that gives you 17 grams. Okay, so for hydrogen chloride, that's HCl, you have 1 plus 35.5. okay, so that should give 36.5 grams. Okay, and of course you can see that ammonia has a lesser mass than what? Than hydrogen chloride gas. So the smaller the mass, the faster the gas will be able to move or diffuse. So B is the correct answer here. Then number 2, 2 grams of powdered calcium carbonate is added to 50 cm³ of hydrochloric acid. Which apparatus is used to measure calcium carbonate and hydrochloric acid? So you need to refer to the state of matter in which they are. Okay, I think that will be helpful here. Calcium carbonate, okay, solid. It was measured. The quantity referred to it's here is mass. Okay, so you have quantity refers to mass as a quantity refers to, and for hydrochloric acid you have volume as the quantity referred to. So you ask yourself what piece of apparatus out of the apparatus here it's suitable for measuring mass of calcium carbonate. So we have mass for calcium carbonate, that should be your balance. Okay, and of course for your volume you have apparatus for measuring volume: burette, pipette, volumetric flask, measuring cylinder, and so on, beaker, and so on. But here we have burette being mentioned, so we have balance, which is correct for this, and of course burette, which is correct for this. So your correct answer here is A. Now question 3, it's on chromatography. Okay, you're asked to calculate the RF value. So to calculate your RF value, you should remember your formula for RF value. Okay, is distance moved by the solute or the substance divided by the distance moved by the solvent. Okay, distance moved, so we have distance distance moved by solute, okay, over distance moved by solvent. Okay, so let's look at that. Distance moved by solute, that is this, okay, 55. So you have your 55 millimeter over distance moved by solvent front, which is equals to 90. Okay, so if you divide that, that should give us okay, let's calculate. Use a calculator. Okay, that's 0.61. Okay, so the correct answer is B. Number 4, which statement about an atom of fluorine is correct? So we need to look at this. Okay, it contains more protons than neutron. So looking at these, we have electrons, you have protons, and you have neutrons. So your electron, it should be equals to the proton number. Proton number is 9, which is atomic number. Electron should be 9, when your proton number is 9. And so if your mass number is 19, then 19 should be equals to neutron number plus what? Plus 9. So that should be 10 plus what? Plus 9. So neutron number is what? Is 10. Okay, so now looking at the option here, it says more protons than neutron. That's not correct. That's not correct because we have lesser proton than what? Than neutron. Okay, it contains 28 protons, neutrons, and electrons. This tells us that when we add all the number, okay, available, all the numbers of subatomic particles available, we should get 28. That simply means if you add 9 plus 9 plus 10, that gives us 28. Okay, this is the correct option there. Okay, well, option C says its isotopes contain different numbers of protons. Okay, isotopes can contain the different number of protons because the term isotope means atoms, okay, of same elements. If they have atoms of the same element, then they will have the same number of protons. Okay, that means they will have the same atomic number. Okay, so isotopes have the same proton number. So this statement is wrong. Okay, its nucleus contains 9 neutrons. We just calculated that our neutron is what? Is 10. So this is also what's wrong. So B is absolutely the correct option. Which row describes the formation of single covalent bonds in methane? So looking at the bonding in methane, methane is CH4. Okay, so the bonding in methane, carbon, okay, plus 4 hydrogen, carbon plus 4 hydrogen, we have that bonding in methane. Okay, bonding in methane. That. So when you look at each of these, your carbon is at the center, your hydrogen, you know, it's hydrogen is at the edges. Okay, carbon is bonding to your hydrogen there. So looking at the nature of this bond, option A says atoms share a pair of electrons. So by elimination method, we can eliminate option C and option D because formation of covalent bonds has nothing to do with transfer. Okay, covalent bonds don't transfer, you know, electrons, so it has to do with sharing. So out of the two options that have to do with sharing, we need to consider these other parts of the question. Let's consider this part so that I'll be able to choose the appropriate, you know, answer. Okay, A says both atoms gain a noble gas electronic structure. Why? Of course, that is the reason why atoms form bond, so that they can attain a stable, you know, electronic configuration or electronic structure. So let's look at option B. It says both atoms have the same number of electrons in the outer shell. We can see that this is not correct. Okay, it's not correct. The atoms do not have the same number of electrons. Carbon and hydrogen do not have the same number of electrons in their outer shell. That's absolutely, even after they have bonded, they still do not have the same number of electrons in the outer shell. After bonding, okay, carbon has 8 electrons in the outer shell if it counts round, while hydrogen has, each of the hydrogen atom will have 2 electrons in the outer shell. Why this, okay, fulfills the noble gas electronic structure. This carbon, attain the octet configuration because it has 8 electrons in the outer shell, while hydrogen attain the duplet configuration like helium because it has 2 electrons in the outer shell. So our correct answer here is A. Okay, you can see that chemistry is not difficult after all. Okay, question 6. Which statement describes the structure of ionic compound? Okay, A, it's a giant lattice of oppositely charged ion. That sounds correct. Okay, it's a giant lattice of positive ions in a sea of electrons. No, this is for metallic bonding. This refers to metallic bonding. Okay, giant molecule of oppositely charged ions. Why ionic compounds have oppositely charged? Okay, but we do not refer to them as giant molecule. Okay, ionic compounds are not simple molecular, okay, even though they have oppositely charged ions. And molecules with simple molecular, like carbon dioxide, okay, like nitrogen, simple molecular, do not contain oppositely charged ions. So this is wrong, and this is wrong. So ionic lattice or ionic compounds are said to have giant ionic lattice, okay, and of course they have oppositely charged ions. The positive and negative ions are held together in giant ionic lattice. Okay, the word lattice simply means you have a regular arrangement of particles, but in this case the particles that are connected together are oppositely charged ions. So we call this a giant ionic lattice. Okay, good. Now the correct answer here is A. So propane bonds in oxygen, which values of X and Y balance the equation. So to balance your equation, you are required to ensure that the number of atoms on the left hand side, which is the reactant side, equals to the number of atoms on on the right hand side. So to balance this equation, what can we do? You need to be able to do it as fast as possible. Okay, so if you look at this particular equation, you have oxygen here, okay, oxygen here, and oxygen, okay, is here too. You have hydrogen here. The only place where you have hydrogen is here. Okay, so if nothing is here, nothing is supposed to be here. So if you have 8 hydrogen and this is 2 here, so you need 4 to multiply this hydrogen to give you 8 hydrogen. That seems to balance what? To balance Y. Okay, so you are suspecting these 2. Now for your X, if 4 is here, okay, so that means you have altogether 3 times 2 will give you 6 oxygen plus 4 in HO. That means you have 4 oxygen to give you what? 10 oxygen altogether. So if you have 10 oxygen and this is the only place where you have oxygen, what do you need to multiply 2 to give you 10? That is 5. Okay, so this is a correct answer. So the equation will be balanced when you have this. Okay, let's balance, look at that and confirm. Okay, the equation 5, okay, we have plus 5O2, okay, to give us 3 CO2 plus 4 H2O. That's perfectly balanced the equation. Okay, number 8. What is the concentration of ascorbic acid when what is the concentration of ascorbic acid when 1 tablet is dissolved in 200 cm cube of water? So we need to first find the mole of ascorbic acid present in 0.08 gram of ascorbic acid. So how do you calculate mole? Number of moles is equals to mass given in grams over relative molecular mass. So in this case, you have 0.08 over 176. 0.08 over 176 should give us 0.08 divided by 176. Okay, that should give us 4.54 4.54 4.54 4.54. So we have 4 point something. So 4.54 times 10 raised to the minus 4. Okay, that's the moles present. So this simply means that we have 4.54 times 10 raised to the minus 4 moles, okay, dissolved in 200 cm cube. So to find the concentration in mole per dm cube, which simply means the amount of in moles dissolved in 1000 cm cube. So therefore, if 4.54 moles dissolves in 200 cm cube, then how many moles will be dissolved in 1000 cm cube? So we're going to have 1000 over 200 cm cube times 4.54 the test for minus 4. Okay, so this should give us, it's okay, 1000 divided by 200 should give us 5. 5 times 4.54 should give us 2.3 times 10 raised to power minus 3 mole per dm cube. So the correct answer is D. Okay, question 9. Which statement about the electrolysis of copper sulfate solution using carbon electrode is correct? Okay, in the electrolysis of copper sulfate solution, we have the cathode, okay, which is the negative electrode, and of course we have the anode, which is the positive electrode. So in the electrolysis of copper sulfate, we have 4 ions there. We have copper ions, we have sulfate ions, then from water we have hydrogen ions and what? Hydroxy ion. These are the 4 ions that will be present there. So the 2 positive ions will migrate towards the cathode. Okay, so both copper and hydrogen will migrate towards the cathode. So we have copper 2 plus here and what? Hydrogen plus. While at the anode is the positive electrode, you have the negative ions migrating to the positive electrode. It's simple. The reason is because unlike charges attracts. So SO4 2 minus and OH minus will migrate towards the anode. So here at the anode we have SO4 2 minus, and of course we have OH minus. Okay, now when they get to the electrode, there is something called the preferential discharge. Both ion migrated towards the electrode, but when they get to the electrode itself will pick the ones it wants preferentially. But there are factors that affect the preferential discharge of ions. Okay, so one of the key factor here has to do with the position of the ion in the reactivity series. Okay, position of the ion. So in this case now, copper is lower than hydrogen in the reactivity series, so therefore copper will be discharged with respect to, or in preference to, hydrogen. So the lower the positive ions are in the reactivity series, the easier their preferential discharge. So copper will be discharged. So if copper is discharged here, okay, that means copper is going to gain, okay, two electrons to form what? To form copper metal, okay, solid copper metal, which is solid, okay, from copper aqueous, okay, here. Now also, so copper metal will stick to the cathode electrode. Okay, definitely the mass of the cathode electrode would increase. Okay, so again, on the anode side, that's the positive electrode, we have sulfate and hydroxide ion migrating there. Okay, the hydroxide ion is lower in the reactivity series than what? Than the sulfate ion. So the hydroxide ion will be discharged in preference to the sulfate ion. When hydroxide ion discharges at the anode, oxygen will be formed. The reaction is simple between 4 hydroxide ion, okay, losing 4 electrons to form water and what? And oxygen. Okay, to balance the equation, this is just balancing the equation. So you can see that at the anode, okay, at the anode, electron is lost, while at the cathode, electrons are what? Are gained. Okay, so let's now go back to the options there and consider the options that we have. A colorless gas is produced at the anode. We have said that oxygen is produced at the anode. Okay, why it's correct that oxygen is a colorless gas. Okay, let's hold on to that. A colorless gas is produced at the cathode. No gas will be produced at the cathode. What is produced at the cathode is what? Is copper. Copper is produced at the cathode, so this is wrong. Okay, the color of the electrolyte remains the same. The color of the electrolyte is not going to remain the same because the electrolyte will have a blue color, because copper sulfate solution has a blue color. But the moment the copper is being taken out of the solution, okay, then you would not expect the color to remain the same. In fact, the color will become more pale. It tends towards colorless because copper is being removed and being stuck to the cathode electrode. Okay, so the solution is not going to remain the same. In fact, the solution will become more acidic, because if when copper is removed and hydroxide, okay, is removed, what will be left will be hydrogen and what? And sulfate. So the solution becomes more acidic. Okay, so hydrogen combined with sulfate to form sulfuric acid, so the solution becomes what? More acidic. So this option is wrong. The mass of both electrodes remain constant. No, the mass of the cathode electrode would increase because copper would have been attached to it, and of course that will increase the mass. So the correct option here is A. Okay, aluminum metal is extracted from aluminum oxide by electrolysis, which half equation describes a reaction that occurs at the electrode. So electrolysis of aluminum oxide, so you have two oxides available, two ions available there. You have aluminum ion Al3 plus available, okay, while you also have the oxygen, ion also what? Available. Oxygen ion will be what? Will be available. Okay, oxygen will be available there. So the ion here will be O2 minus. So we have 3 of these oxygen ion available. So basically, at the cathode and of course at the anode. Okay, the cathode is the negative electrode, the anode is the positive electrode. So aluminium migrate towards the cathode while oxygen migrate towards the what? Towards the anode. Okay, so what happened at the anode? At the anode, oxygen is going to lose electron. Oxygen is going to lose electron. Okay, while at the cathode, aluminium is going to gain what? Electron. So looking at the option there, this is wrong because aluminium will not migrate towards the anode. It's wrong. Oxygen will not migrate towards the cathode. This is also wrong. So we have A and D left to consider. A and D left to consider. Okay. While looking at this equation, it is true that this equation shows that oxygen will lose electron. Okay, it shows that oxygen will lose electron. Okay, because let me rewrite the equation so that you see what is written there. O2 minus, they are telling us that this is what happened there. O. Okay, so if this moves to this other side, it becomes positive, and that is what you see written in the option there. But why this is possible, the only thing wrong with this is that one oxygen atom, okay, will lose 2 electrons, but 2 oxygen atoms will lose 4 electrons. So this should have been O2 minus 4E minus in order to be able to form O2. So the balancing of equation is wrong. This should be 4 electrons. So A is also wrong. So D is the correct option here. One aluminium atom will gain 3 electrons to form what? 1 atom of aluminium. So D is the correct option here. Question 11. Which statement about the hydrogen fuel cell is not correct? Okay, the hydrogen fuel cell is one of the focus for green, energy. Okay, it helps to prevent pollution. You need to just revise that. Okay, the chemical energy is converted to electrical energy. Okay, hydrogen is oxidized. Okay, then the reaction takes place. That takes place is endothermic. No, the reaction is not endothermic. The reaction that takes place here is actually, hydrogen. Okay, and oxygen that gives us essentially, water. So this reaction is an exothermic reaction. Okay, water is the only product. Okay, while this is correct, water is the only product. Hydrogen is oxidized. If you look at the reaction, oxygen is added to hydrogen, so it's like an oxidation reaction for what? Hydrogen. And of course, the essence of this chemical reaction is to produce electrical energy. That's the essence of the hydrogen fuel cell. Okay, of course, if you even look at the definition of the word cell, it's a device that converts chemical energy into electrical energy. Okay, so the only wrong option statement here is C. So C will be the correct answer for this question. Okay, now question 12. Nitrogen reacts with hydrogen to produce ammonia. The reaction is exothermic. The bond energies are shown in the table. So here we want to do enthalpy, calculating bond energy. So in order to be able to solve a problem like this, you need a sound understanding of your covalent bonding. Okay, so we need to look at bond broken and versus what? Bond formed. Bond broken versus bond formed. So here these bonds will be broken. You have bonds will be broken in nitrogen. Okay, you have this. Okay, plus 3 of these. Okay, H to H. You can see that's on the reactant side. So we have 945, okay, kilojoule per mole broken, plus 3 times hydrogen to hydrogen, value is 436. Okay, so that should give us 945 plus 436 times 3 should give 1308. Okay, so adding all that together, we should get 2, 2, 5, yeah, 3. Okay, because here bond is being broken, so bond broken means that it's an endothermic what reaction. So we put in our sign here, which is 2, 2, 5, 3. Please, you need to record that. Okay, endothermic, okay, is represented by positive. That means energy absorbed, energy taken in, and this, happen whenever bonds are what are broken. It's equivalent to breaking what breaking of bond. Okay, the opposite is for exothermic. For exothermic, you use your negative sign. It means that energy is released when bonds are what formed. Energy is released when bonds are formed. So we have taken care of this reactant side. Now on the product side, the product form is ammonia, and ammonia is this. Okay, that simply means that we have, per molecule of ammonia, we have 3 N to H bond, 3 of these, but because we have 2 here, so we have this is multiplied by 2, so therefore I'm going to be having 6 nitrogen to hydrogen bond. So 6 times, what is the value there? 390. 6 times 390 should give me 2340. Okay, but because this is bond formation releases energy, so this value is going to be negative value. Okay, negative value. So if I compare this to this, okay, find the net value, minus 2340. Okay, if I sum it with my positive 2253, I'm going to be getting minus 87 kilojoule. So the correct answer here is what is B. Okay, that's interesting really. Which change in reaction condition increases both the collision rate and the proportion of molecules with sufficient energy to react? So we are looking at factors affecting the rate of reaction. Okay, factors affecting the rate of reaction. We'll talk about presence of catalyst is 1. Okay, increase, concentration is 1. Pressure, okay, is 1. And of course temperature is 1. Okay, each of these affect the rate of reaction in different way. Okay, they tamper with different things to affect the rate of reaction. Now increase in temperature increases the energy of the molecule. In fact, that's the only factor that increases the energy of what of the molecule. So it increases the energy of the molecule. If you increase the temperature of colliding particles, they'll be able to move faster, they will collide harder because they have increased what energy. Okay, so basically here it is what increasing the temperature of the reactant, increasing the surface area. Yeah, I left that out. Surface area is also one of the factors affecting the reaction. When you increase the surface area, you're not increasing the energy of the reacting molecule, you're only making other conditions suitable. You're exposing the particles for better collision, but the energy they have will not increase. Okay, if you use catalyst does not increase the energy of the colliding particles, it only lowers the requirement, which is called the activation energy. Oh, that's what catalyst does. Concentration on another hands actually shortens the time the molecules need to travel before they collide, because the more of the particles you have in a given space, the lesser the distance they need to move before they collide, and of course that will increase the rate of reaction too. Okay, now question 14. When blue-green crystals of nickel sulfate are heated, water is produced and a yellow solid remains. When water is added to the yellow solid, the blue-green color returns. Which process describes this change? Okay, so you have a substance, okay, which is blue, okay, bluish green. Okay, now when it is heated, heat energy is applied to it, it produces another solid which is yellow. Okay, and water is what water is driven off. So if you look at this, in the reverse, if you add water to the yellow substance, if you add water to this yellow substance, it gives you this particular blue-green color returns. So I have my sign here. That's a sign for what? Reversible reaction. So this is a reversible reaction. Okay, it's a purely a reversible reaction. Now, question 15. The graph shows how the yield of product in a reversible reaction changes as the temperature and pressure are changed. Okay, so we are talking about equilibrium here and factors affecting the position of equilibrium, and this relates to yield. So we are focusing on temperature and what? And pressure. Okay, so all reactants and products are gases, so we are focusing on this. Now, looking at this diagram, to be able to understand the diagram better, let me explain that. Now, you have your yield here and you have your pressure here. Looking at this alone and ignoring this particular part of it, okay, looking at the yield, that tells us that if I have this, okay, I have my product here and I have pressure here. So if my graph is like this, okay, that simply means that, and I have something like this, okay, that means that as the pressure increases, I'll have lower what? I'll have lower product. This is product 1, and this is what? My pressure 1. You can see that. So now when my pressure increases to B, my product, okay, falls down to P2. So increase in pressure, okay, reduces the product form. Increase in pressure reduces the product form according to this graph. That's what this graph is saying. Okay, so what's the implication of that? So we want to see in an equilibrium reaction, a reversible reaction at equilibrium, okay, if increase in pressure reduces the product, increase in pressure reduces the product, increase in pressure reduces the product. So increase in pressure always favor the side with fewer moles. Increase in pressure favors the side with fewer moles. For example, if I have a reversible reaction like this, okay, and I have 3 moles of reactant here and I have 2 moles of product here. If increase in pressure, if the pressure is increased, the reaction will favor the side with fewer moles. If the pressure is increased, the reaction, the equilibrium position will shift to the side with fewer moles. If the pressure is reduced, the equilibrium will shift to the side with more moles. I'll take that again. How does pressure affect the position of equilibrium? So for a system that is gaseous, okay, both reactant and product are gaseous. Now you need to first calculate the amount in moles on the reactant side versus the amount in moles on the product side. So I'm giving an example here. On the reactant side, let's assume I have 3 moles. On the product side, I have 2 moles of product. If I increase the pressure, the equilibrium will shift to the product side. That means I'll have more of my product being formed. If I reduce the pressure, equilibrium will attempt to increase the pressure. And how will equilibrium do that? Equilibrium will favor the side with more moles. There is a principle that attaches to this called the Leto-Chilia principle. That principle simply states that if there is a change in any of the factors affecting the position of equilibrium, equilibrium will shift in such a way to annul, to nullify, to counter, to change the factor, the change in the factor that has been affected. So if I increase the pressure, for this particular example that I'm giving, equilibrium will shift to the side with 2 moles because that is the side with fewer moles. Now, how does that affect this particular question that we are looking at? Okay, it was said, looking at this, increase in pressure, okay, does not favor the product side, because as the pressure increases, less of the product is being formed. That means that more of the reactant is being formed. So the backward reaction is favored. Increase in pressure favors the backward reaction here. So that means increase in pressure favors the side with fewer moles. So therefore the reactant side will be the side with fewer moles, since increasing the pressure leads to less products being formed, and that means more of this reactant being formed in the reverse reaction. Okay, so looking at my option here, okay, so it says side with fewer moles. So I have two options that give me reactant. So this one that say product inside with fewer moles will be wrong, so I'm not considering them. So let me consider that of temperature now, how temperature affect this reaction. Now if you look at this particular reaction, moving from 100 degree down to 300 degree, so this tells us that increase in temperature actually increases what? Increases the yield. Okay, increase in temperature increases what? Increases the yield of reaction. Okay, at 100 degrees Celsius, this is where the production yield curve is. What this is a higher, this indicates a higher what? Yield. So increase in temperature increases the yield. Now how does temperature affect reaction at equilibrium? If the reaction at affect the reaction at equilibrium, if the reaction is an exothermic reaction, the forward direction will be favored by reducing temperature. If the reaction is an exothermic reaction, the forward will be favored by reducing what? Temperature. But if you look at this particular reaction, increase in temperature favors the product, favors the formation of the product. That means increase in temperature favors the forward reaction. Increase in temperature favors the forward reaction. So if increase in temperature favors the forward reaction, okay, the reaction that is favored by increase in temperature is an endothermic reaction, because an endothermic reaction requires the temperature, requires heat energy. So if you are increasing the temperature, you are doing it a favor. Why an exothermic reaction does not require temperature. In fact, it doesn't need it. That is why it releases it to the atmosphere. So if something does not need heat energy and you are giving it heat energy, you are hampering the reaction that needs to go on. So the backward reaction will be favored. So in this case, the forward reaction is favored by increase in temperature that leads to more yield of product. So the correct option here is endothermic. So B is the correct option. Okay, now which changes represent oxidation? Which changes represent oxidation? So basically oxidation reaction, okay, is the loss of electron, okay. So in which reaction is electron lost? So you need to check that. You also need to know that oxidation can be defined as increase in oxidation number. So we'll combine the two definitions, okay, or increase in oxidation number. Okay, so here, what's the oxidation number of iodine here? Oxidation number of iodine here is -1. Okay, here it is what? 0. Okay, when an element is in its uncombined state, its oxidation number is 0. Okay, for a charged atom, the oxidation number is the valency, the charge it is carrying. Okay, so we'll get that. So if you move from -1 to 0, that's an increase in oxidation number. Okay, and so this is correct. Now for chromium 6 means that the oxidation number of chromium is 6. Chromium 3 means the oxidation number of chromium here is 3 plus, while here is 6 plus. Okay, this is decrease in oxidation number. This is reduction. Moving from 6 to 3 is decrease. That is what reduction. Okay, so the third option, +2 to +3. Okay, that is 2 to 3. That's increase in oxidation number. So that is 1 and what 3. Okay, B is the correct answer. Now, looking at this question, it says they do not react with acid or bases. They do not react with acid or bases. Okay, and they are all non-metallic oxide. Okay, so if they do not react with acid, if an oxide is an acidic oxide, okay, acidic oxide, okay, will react with what? With base. A basic oxide will react with what? An acid. An amphoteric oxide is an oxide that has both basic and what? Acidic properties. So an amphoteric oxide will react with both base and what? And acid. Okay, so a neutral oxide, okay, we react with none. Okay, so the correct option here is D. Correct option is D. Now, moving to the periodic table question. Which of the following W, X, Y, Z in the periodic table, okay, which elements form basic oxide? So elements that form basic oxides are actually metals. Basic oxides are oxides of metals. Okay, so we need to find out which one of these, okay, are oxide. Which one of these are metals rather. Okay, this is group 1 metal, this is group 2 metal, and this is a transition word metal. Okay, so W, X, Y, yes, W, X, and what? And Y. Okay, Z is a non-metal. This is group 7 of the periodic table. So, okay, this is halogen. Okay, so halogens don't form basic oxide. Okay, number 19. Ethanoic acid is a weak acid. Hydrochloric acid is a strong acid. Which statement is correct? Okay, ethanoic acid molecules are partially dissociated in water. So now, what makes a substance a weak acid and what makes another one a strong acid? Weak acid, they partially dissociate. Okay, they partially what? Dissociate in solution. Why? Strong acid, okay, they fully dissociate. Okay, so ethanoic acid molecule partially dissociated into ions. Okay, that seems correct. Yeah, because it's a weak acid. Okay, now 1 mole per dm³ of ethanoic acid has a higher pH than what? Than 1 mole per dm³ of hydrochloric acid. When you talk about pH and concentration of hydrogen ions, so you need to know the relationship between concentration of, this is how we represent concentration, okay, of ions in chemistry. So we're doing concentration versus pH now. Okay, the higher the concentration of hydrogen ion, the lower the what? The pH. Okay, the lower the concentration of hydrogen ion, the higher the what? The pH. Now, 1 mole per dm³ of ethanoic acid, okay, we have lesser hydrogen ion concentration because it dissociates partially. So when 1 mole of ethanoic acid dissociates, you have lesser hydrogen ion concentration entering into the water compared to when 1 mole of hydrochloric acid dissociate, because 1 mole of hydrochloric acid, being a strong acid, would dissociate completely. For example, if I have 100, okay, moles of hydrogen ion available in hydrochloric acid, I will have 100 moles of hydrogen ion dissociating. But if I have 100 mole of ethanoic acid, hydrogen in ethanoic acid, okay, I may end up having like 10% or even less than that dissociating. So the fact that it is 1 mole does not mean we have equal amounts of hydrogen ion entering into the solution when each of the acid, okay, dissociates in solution. So in this case now, in essence, 1 mole of ethanoic acid will produce lesser hydrogen ion concentration. So lesser hydrogen ion concentration means higher pH. You can see this. Lesser hydrogen ion concentration means what? Higher pH. That is very okay. This means this is what we are looking at. Means, you know, lesser hydrogen ion concentration means what? Higher pH. Okay, so for higher pH, that means this statement is correct. Okay, it has a higher pH than what? Than hydrochloric acid. But because for hydrochloric acid it has more hydrogen ion concentration and of course a lower what? Lower pH. Okay, that statement seems correct, you know. Two, ethanoic acid is always more dilute than hydrochloric acid. No, this is not correct. Okay, ethanoic acid is a proton acceptor. Acids are proton donor. Acids are proton donor. Acids are they are proton donors. Okay, acids are proton donors, so they are not proton acceptor. So the correct option here is 1 and 2. So A is the right answer. So A is correct. Okay. Now question 20. The properties of an element are shown, okay, below. Which element has this property? This element has high conductivity, low density, and react violently with water. So non-metals do not have high electrical conductivity. So metals have high electrical conductivity. So we are initially suspecting. So this guy are what? Suspect, because they are the metals here. Okay, but this is a transition metal. Transition metals have high density. They have high density. Okay, they have high density. So this can fit it. Okay, so C is wrong. Okay, also A could have, okay, low density, D could have low density, A, but and high electrical conductivity just like C. But in terms of reaction with water, A does not react violently with water. In fact, looking at your periodic table, A here is your magnesium. Okay, magnesium does not react violently with cold water. In fact, reaction with cold water seems to be so negligible. It happens so slowly, if at all. So magnesium actually reacts with steam. Okay, that's when they react with steam to form, you know, your magnesium oxide. Okay, now basically the correct answer here would be D. D is, in fact, this D is francium. You can see it's reacting violently with water. It has low density and it has what? High electrical what? Conductivity. So francium, okay, has the higher density in group 1, but compared to other metals, francium density is lower because alkaline metals, one of the properties that they have low what? They have low density. Okay, so the correct answer here is D. Correct answer is D. Now, which statement about elements in group 1 and group 7 of the periodic table is correct? Which statement about elements in group 1 and group 7 of the periodic table is correct? Okay, bromine reacts with potassium chloride to produce chlorine. Okay, now if you say bromine, okay, plus potassium chloride to produce you have this plus chlorine. Okay, now this reaction does not seem to be possible because bromine cannot displace chlorine from, you know, from its compound, because bromine is lower than chlorine in the reactivity series. So this is wrong. Iodine is a monoatomic non-methanol. Iodine exists as diatomic. Lithium has a higher melting point than potassium. Okay, that's correct. Sodium is more reactive than potassium. No, reactivity increases down the group in group 1. Okay, while the melting point, okay, decreases down the group. density increases down the group. Very important to know that density increases down the group, melting point decreases down the group, reactivity increases down the group. Okay, so the correct answer here is a C. Which statement about elements in group 8 of the periodic table is correct? They have full outer shells of electron. Yes, noble gases have full outer shell of electron. So that's correct. No wasting of time with this. Okay, they all react with group 1 element to form ionic compounds. Noble gases don't react. Okay, they are all diatomic. Noble gases don't form molecules. They don't form diatomic. They are not diatomic in essence. Okay, they are all liquids at room temperature. They are gases at room temperature. So A is the correct answer. 23. Which statement correctly describe X and Y? There are two substances used to make electrical conductor. Okay, looking at this diagram, okay, all you have here is just elements, and because they are arranged in lattice, okay, so we can say that X represents metal. Why are we saying they are metals? Because they have electrical conductivity, and we can see them arranged in a lattice. Okay, and of course this is not ions, because these similar balls shows that they have the same atoms of the same element. So this means pure metals, right? Okay, good. Now the second part, why this is metals, but you can see this is different from others. Okay, so this looks like the diagram representing alloys. Okay, this is pure metal. Pure metal contains the same elements arranged in lattice, and they conduct electricity, so that makes them pure metal. Why this, the fact that it conducts electricity and it's in lattice form, means it's metallic, but it's an alloy. Alloy is a mixture of what? Mixtures of metals. Okay, so since it conducts electricity, then that means they will be metallic, and because we have different types, this is different from this, so it means that they are different metals, or a metal and a non-metal. Okay, in this case, so we call them what? Alloy. So B is our correct answer to that. Now 24. Question 24. Okay, 3 metals compound PQR are heated using a Bunsen burner. Okay, so we have the results given here. Colorless gas produced which relight a glowing splint. Okay, so what gas does that? That's oxygen. Oxygen, the test for oxygen, it rekindles glowing splint. A colorless gas produces turn lime water milky. That's carbon dioxide. Turns lime water milky. Okay, R, no reaction. So which will represent P, Q, and R? So for P here, something that could decompose to give us oxygen. Well, if carbonate decompose, carbonate will not give oxygen. Carbonate will decompose to form carbon dioxide. When carbonate decomposes, it breaks down to form carbon dioxide. Where carbonate of less reactive metals, okay, decompose to form the oxide, and of course the carbon, and for carbon dioxide. So A and B will be wrong, because P, the composition of this carbonate will not produce oxygen, and in P oxygen was produced. Okay, so let's look at C and D. Potassium nitrate. Potassium nitrate. You need to understand the composition of metal compounds. When nitrates of reactive metals decompose, potassium for example, when nitrate of potassium decompose, is going to form nitrite, potassium nitrite plus oxygen. That's what will be formed. Potassium nitrite plus oxygen. Nitrate of moderately reactive metals will produce 3 products. For example, magnesium nitrate, just so you know, magnesium nitrate, when it decomposes, is going to form 3 products. That is magnesium, it's going to form magnesium oxide plus nitrogen dioxide, yes, plus oxygen. So balance this equation. I could have 2 here. This is magnesium nitrate, which is moderately reactive metal. They produce 3 products when they are nitrate decomposed. But for potassium nitrate, which is a nitrate of reactive metal, it produces two products. Okay, it produces a nitrite and what? An oxygen. Okay, so yeah, you want to put potassium nitrate, so any of these will be correct. Okay, because oxygen is produced by P. Then why Q will be the decomposition of a carbonate. So the correct answer here is what? The correct answer is C. Correct answer is C. Okay, potassium carbonate will not decompose when heated by a Bunsen burner, because carbonate of highly reactive metals do not decompose, okay, easily by heat. It takes a great amount of heat energy, if at all, to decompose them. So C is the correct answer. Question 25. Question 25. Zinc is extracted from its ore zinc blend using two chemical reactions. There. Okay. Which substance is reduced in reaction 1 and 2? This is roasting. This is roasting of zinc blend. Okay. That is, zinc blend is roasted here. Then of course you have reduction of zinc oxide. So, but let's just look at that. Which substance is asking? Which substance is reduced? Okay, here we have zinc sulfide, okay, reacting with oxygen. So oxygen is being reduced here because the oxidation number of oxygen, okay, for example here is 0, but here is what? Is -2. So oxygen, while here is 0, okay, 2, but oxygen is moving from 0 to -2. That is reduction. So oxygen is being reduced. So A or B will be correct. Okay, so this is wrong, this is wrong, because zinc sulfide is not being reduced there. Okay, now in the second part, which substance is being reduced? Okay, this is reduction of zinc oxide. Okay, you can see zinc here, oxidation number of zinc here is 2 plus. Now here zinc is 0, so you can see zinc is moving from 2 plus to what? To 0. That is decrease in oxidation number, so that is reduction. So what is being reduced here? We have oxygen and what? And zinc oxide. So the correct answer is B. 26. 4 metals, okay, are compared here, are reacted with aqueous solutions of their nitrate. So basically, if you have a table like this, you are simply finding out the extent to which each of the metals are reactive. Okay, so if you look at this, magnesium tends to react with 3 things. Okay, zinc reacted with 2, M metal reacted with only 1, while copper reacted with none. So the one that reacted with none basically is the least reactive. So you are supposed to arrange the metals in, say, starting with the most reactive. Okay, so you can see if magnesium can react with the compound of metal M to displace metal M, then magnesium is more reactive than metal M. If magnesium can displace copper from its nitrate, magnesium is more reactive than copper. If magnesium can displace zinc from its nitrate, then magnesium is more reactive than zinc. That means magnesium is the most reactive of all. So starting with the most reactive, so A and B out of the way, you are left with B and C and D, because you have found out that magnesium is the most reactive here. So let's look at zinc. Zinc can displace metal M. Zinc can displace metal M. You can see here it was thick. So if zinc can displace metal M, then that means that after magnesium, okay, is zinc that follows next. After magnesium, zinc that follows next, not this. So D is the correct answer. You don't need to finish the analysis because of time. That's how to save time in solving MCQ questions, especially in exam. Why is aluminum used to make containers for storing food? Okay, electrical conductivity. We don't need electrical conductivity for storing food. It has high melting point. Don't necessarily need that for storage of food. It's resistant to corrosion. That seems so so strong. It is strong. You don't need really strong material, for to store food. Okay, so it is resistant to corrosion. Aluminum is resistant to corrosion, so it helps to prevent food spoilage when aluminum corrodes. But in this case, aluminum doesn't, it doesn't corrode. It's resistant to corrosion, so the food is what is safe. The correct answer is C. Water can be treated by filtration, then chlorination, which uses do not need water for this quality. Okay, for cooling in industry, we really do not need water to. Okay, for cooling in industry, yeah, we do not need water to be chlorinated before we can use it for cooling. It doesn't need high level of purity. Okay, water for washing, we don't need water for washing clothes to be this level of purity. Okay, but water for drinking requires that. Okay, requires that level of purity. Filtration, then chlorination. So the ones that do not require these are one and what and two. So the correct answer here is what is B. Now question 29. Oxides of nitrogen are formed in car engines and are sources of air pollution. To decrease this pollution, catalytic converters are fitted to car exhaust. What happens to the oxides of nitrogen in the catalytic converter? Okay, so an understanding of catalytic converter is very important. Oxides of nitrogen. How is the oxide of nitrogen formed? Nitrogen, okay, first reacting with oxygen to form nitrogen oxide, or you can form nitrogen dioxide. The equation is not balanced. Okay, just use that as an illustration. So when the oxides of nitrogen are produced, how do catalytic converters take them away? Okay, nitrogen monoxide, okay, react with carbon monoxide, okay, which is also another oxide formed in the car exhaust to form nitrogen and of course carbon dioxide. So to balance this equation, you have two. So this balances the equation. You can see here. So let's look at what happened to nitrogen oxide here. Nitrogen oxide is reduced to what? To nitrogen. Reduced to nitrogen. That's just pretty straightforward. You can see oxygen is taken away from it. Reduction is the removal of oxygen, while oxidation is the addition of oxygen. So the correct answer here is what? So what catalytic converter does there is to reduce the oxides of nitrogen to nitrogen, while it oxidizes the oxide of carbon to carbon dioxide. Okay, now question 30. The diagram shows an experiment to investigate how paint affect the rusting of iron. What happened to the water level in tubes P and Q? Tubes P and Q. Okay, so this is iron, okay, and this is painted iron. Of course, you know that painting prevents rusting. So air is available and water is what? Water is available. Okay, air is available and water is available. These are two conditions required for what? For rusting to take place. So if iron takes air, oxygen in, and of course water vapor in here, we would expect that the pressure in this particular tube will reduce, because iron, okay, iron has taken oxygen and what? And water, okay, vapor, okay, to form, rust. That form rust, iron 3 oxide. Okay, so the pressure here in the tube will reduce. When the pressure reduces, we would expect water to flow in, to rise in the tube. Okay, so in tube P, in tube P, we would expect that the level of water will rise. Okay, the level of water will rise in tube P. Okay, while here the level of water will be maintained. Okay, so the correct answer here is D. Question 31. Ammonia is manufactured by the Haber process. The forward reaction is exothermic, which condition maximizes the yield of ammonia. Okay, so there are two things here: pressure and what? temperature. Pressure and temperature. Now, exothermic reaction is favored by decrease in temperature. Exothermic reaction is favored by decrease in temperature. Because it is exothermic, it means that the reaction itself is heat energy producing. So it doesn't need you to add heat energy to it. So when heat energy is added to an exothermic reaction, okay, it hampers the progress. So in this particular case, the forward reaction is favored by decrease in temperature. Decrease in temperature. The forward reaction is favored by decrease in temperature. Forward reaction, you have decrease in temperature. Okay, because an exothermic reaction. The backward reaction is endo. Okay, it is favored by what? Increase in temperature, because endothermic reaction absorb heat energy. So when you're putting in heat and energy, it requires it, it takes it in, it likes it, so you're favoring it. Okay, so now, so we're looking at those options that have low temperature to increase yield. Okay, so A and D and C are out of the way. So let's consider pressure. Now, to consider how pressure affect the position of equilibrium, the first thing you have to do, you have to count the number of moles of reactant and that of product. So for the reactant here, I have 1 plus 3, and that gives me 4. Okay, moles of reactant available, while here I have 2 moles of what? Product available. Okay, so increase in pressure favors the side with lesser moles. Increase in pressure. Okay, when you increase the pressure, equilibrium will favor the side with lesser mole. When you decrease the pressure, equilibrium will favor the side with more moles. So what happened here? Okay, to maximize yield here, the side with lesser moles, which is the production of ammonia, needs to be favored. So what we need to do is to what? Is to increase what? Increase yield. So high pressure will favor, will make the reaction move towards this side by high pressure. So correct answer is what? Is B. Now 32 here. Okay, which row describes processes X, Y, Z? So let's look at it. You have animal. Okay, atmospheric carbon dioxide, that is when they respiration. Okay, that's how animal will produce carbon dioxide into the atmosphere. Okay, then another way, what happens to the animal death, excretion, dead organic matter. Then why? Dead organic matter to atmospheric carbon dioxide. Dead organic matter to that should be combustion. Yes, combustion. Okay, plant material, animal material, atmospheric carbon dioxide, combustion. Okay, then we have atmospheric carbon dioxide being absorbed into green plant. Of course, that's photosynthesis. Okay, green plants use carbon dioxide and water to photosynthesize. So we have X is photosynthesis. Okay, C and D seems correct. Y is combustion. Yeah, so C is the correct option here. C is the correct option. So let's look at question 33. Which row shows the conditions used in contact process? Which row shows the conditions used in contact process? In contact process, we have series of reactions happening in contact process. Okay, we have a reaction in which your sulfur, okay, react with oxygen to produce your sulfur dioxide. Then one of the reactions is equilibrium reaction, in which your sulfur dioxide is further reacted with oxygen to produce sulfur trioxide. That's an exothermic reaction. It has enthalpy of around minus 197 kilojoule per mole, like that. Okay, but that's not relevant for this. Now, this particular reaction is an equilibrium reaction that requires, vanadium 5 oxide, okay, vanadium 5 oxide as the catalyst here, okay, and of course it requires high temperature, about 450 degrees Celsius, and 2 atmosphere. That's what the reaction needs. Just this is a white hat, kind of it's a fact-based question. So you need to memorize the condition required for contact process, Heber process, and a few other stuff like that. Okay, so now question 34. Question 34. This was C, right? We chose C. 32. No, sorry. Yeah, correct. Yeah. Question 34. Looking at this diagram, that is decomposition of limestone. When limestone decomposes, what do we form? Okay, it decomposes to form calcium oxide plus carbon what? Dioxide. Okay, so this is showing the kiln where it is formed. So we'd expect that calcium carbonate, which is born by air, and what we call a fuel, producing the thermal energy required to burn the limestone. Your carbon dioxide, okay, escaped here. Then of course the product required here is your calcium oxide, okay, calcium oxide. So the correct answer here is C. C is the correct answer. Okay, now which fuel could be gasoline? Okay, so this is talking about the uses of petroleum fraction. Which fuel could be gasoline? Is it obtained from petroleum? If it's obtained from petroleum, yes. Okay, if it's used by car for fuel, okay, it says used by car for fuel and it's taken from petroleum fraction, then A is gasoline. A is gasoline. Okay, that's petrol. It's just as simple as that. Question 36. Okay, why is ethanol a member of the homologous series of alcohol but propane is not? Okay, characteristics of homologous series. Homologous series have general method of preparation. Okay, method of preparation. Okay, they have the same general molecular formula. Members of the same homologous series will have the same functional group. Very important. They have the same functional group. Okay, now each member differs by what? By CH2. Okay, so ethanol has 2 carbon atoms per molecule, but propane has 3. No, that doesn't mean that they won't be member of homologous series. For example, methane is CH4, while ethane is C2. Ethane is C2H6. Okay, so that doesn't mean they're not the same homologous series. So the number of carbon atom does not affect it here. Ethanol can be made from ethane, but propane is obtained from petroleum. Ethanol can be made from ethane, but propane is obtained from petroleum. Okay, that's not sufficient reason. C, ethanol is a liquid but propane is a gas. No, members of a particular homologous series can vary from gas to liquid to what? To solid, depending on the number of what? Carbon atoms. Okay, ethanol contains the same functional group, same functional group as other alcohols, but propane does not. So the functional group of alcohol differs from what? Alkane. So they are not of the same homologous family. 37. Chlorine reacts with methane. Which statements are correct? The reaction takes place in the dark. Okay, no, methane is an alkane, and alkanes are generally unreactive. So reactions of alkane with chlorine, okay, it's a photochemical reaction. So it can't take place in the dark. It's photochemical, so it can't take place in the dark. Reaction of chlorine with methane forms chloromethane. Correct. Chloromethane, okay, reacts with chlorine to produce dichloromethane. Okay, the reaction of chlorine with methane is an addition reaction. No, that is a substitution reaction. Substitution reaction is reaction of chlorine with methane, chlorine with ethane, okay, or alkane. That is addition what reaction. So the correct answer here is 2 and 3. 2 and 3. So T. C. Question 38. Okay, question 38. Which statement about aqueous ethanoic acid are correct? Ethanoic acid contains functional group. Yes, that's correct. Contains that functional group. Okay, ethanoic acid react with carbonate to produce hydrogen. No, acid react with carbonate to produce carbon dioxide. Okay, that's pretty straightforward. Ethanoic acid turns universal indicator blue. No, acid reacts with universal indicator paper to form reddish or orange color. Okay, so a base would do this. Ethanoic acid has a lower pH than 7. Yes, the pH of acid are less than what? 7. So the correct answer is C. Okay, question 39. What is the name of the ester? Now, to name ester, you have to start from this side to name ester. Okay, good. So start from this side, not from this side. This side, okay, is the side that carries the double bond. You start from there. You start from what? This side. See, you have R1, okay, double bond OR. So you usually start from this side. Okay, start from that side, name it that way. Okay, so how many carbon do we have here? 1, 2, 3. So this is prop P, because it's an attached group. Now it's prop P. Then you name this now 1 and 2. That is ethanoate. So we have prop P ethanoate. Okay, the last question: which type of polymer is shown and by which process is it formed? Okay, so if you look at this polymer structure, we have here in the option we have carbohydrate and polyester. Okay, now ester is usually formed between alcohol and carboxylic acid. Ester is usually formed between alcohol and carboxylic acid. But if you look at this, we do not have carbon, double bond to oxygen in any of these diagrams. So there is no ester here. This is more like a carbohydrate. For example, glucose. Okay, that's a polyhol, if you like, with another, glucose. Okay, will come together to give in a condensation. Okay, in a condensation reaction where you have this is taken, okay, and you're going to be forming, this is taken and it will be lost as what? As water. So you have your substance being formed. O is left and this is left on this other side, H, okay, H, but the focus is just this bond you can see here. So it's more like carbohydrate. That's glucose is an example here, carbohydrate, and it's a condensation reaction. Why is a condensation reaction? Water molecule is what? Is lost. Okay, so the correct answer here is B. Okay, yeah, I hope you've had a nice time learning. This is me signing out. Okay, you can, yes.